In today's session, I'll be discussing about gravitation. Under gravitation, we'll be studying the following concepts: universal law of gravitation, then we'll discuss about the free fall. What do you mean by free fall? Where from? Let us try to explore the value of G. To find the value of G, then of course we are already aware of the Newton's law of motion, but here we will be studying about the motion under the gravity. Under the influence of gravity. Then we will be explaining about the difference between mass and weight. Mass versus weight. So these are the major topics, and as per your old syllabus, they included thrust also. Thrust and pressure. Then Archimedes principle, though it is not included in your present syllabus, but you should know about this Archimedes principle. Then I'll be explaining about the relative density. So these are the various concepts we will be discussing in this class. Okay. Now let us go one by one. First of all, we will try to understand what gravitation is. It is the force of attraction. Between two particles. Between any two particles, or you can say bodies in the universe. And this force of attraction due to gravity is also called the gravitational force. So gravitation force. So what do you mean by gravitation force? It is due to the earth, is it not? Okay, so this is also called due to earth is called gravity. So what is gravity? Gravitational force due to earth is called gravity. I said the force of attraction. The force of attraction between two any bodies means you have got one body with mass m. Let me say m1 and another mass m2. And the distance between the center of these two masses is called a d. Therefore, according to Newton's law, universal law of gravitation, Newton's law of gravitation, force is directly proportional to the product of the masses. Okay? And the same force is inversely proportional to the square of the distance between them. Now we can combine these two. Therefore, F is proportional to m1 m2 divided by d squared. Now when we want to remove the proportionality, you have to introduce a constant, and that constant is called G, capital G, that is universal what? Gravitational constant. So F is equal to, I am removing the proportionality and introduce G. So G into m1 m2 divided by d square. Now let us analyze the unit of all the parameters given here. This is called universal law of gravitation, and you can put Newton's universal law of gravitation. Now let us see the unit of G. You should always find out the unit of any proportionality constant based on the known units of other parameters. For example, we know F is equal to G into m1 m2 divided by d squared. Now, what do you mean by this F? The force of interaction between two bodies, and G, gravitational constant. Then m1 m2, the masses of two bodies. D, the distance between the two masses or two objects. Two objects. Now let us have this G. So it is F into d squared divided by m1 m2. Is it not? We can rearrange. And what is the unit for force? Newton. And we want to find out the unit of G. For masses it is kg. The distance between them is meter. So we can substitute Newton meter squared, is it not, divided by m1 m2 means kg squared. Okay, so you can declare this the unit of G, universal constant for gravity, no? So is Newton meter squared kg power minus 2. Is it, or it can go up? So kg squared becomes kg power minus 2. Right? And its value is found to be the value of G is equal to 6.67 into 10 power minus 11 Newton meter square per kg squared, or kg power minus 2. Okay. Now let us try to find out the value of G, that is small g, that is called acceleration due to gravity. Okay, take down. Let us relate G versus capital G, right? Now we know force is equal to ma, mass into acceleration, according to Newton's second law. But in case of an object falling freely, okay, towards the earth, that is known as acceleration due to gravity. So G is replaced by A. A is replaced by G. So A becomes a G here. Therefore, now the gravitational force is mg, that is for freely falling force. Is it not? Now, this force is due to the attraction, so we can compare these two forces. Acceleration, gravitational force is equal to G into m1 into m2 divided by d squared. In the case of an earth like this, okay, now an object is falling from a certain height, but compared to the radius of the earth, this distance is ignored, so you can call it r. So this is the mass of what? The object. Okay, now this distance is, that is the distance or the height of the object from the earth's crust or the earth's surface is ignored because this radius is very high, that is this may be h. Actually you have to consider for d, that is d is equal to, this is the mass of earth and this is the object. So m, capital M, is the mass of earth. Mass of earth. And what about the d, which is nothing but radius of the earth plus height of the object. Now r is much bigger than h, therefore d is equally replaced by r. So this is nothing but r is a radius of earth, is it not? Earth. Now we can convert this equation, that is F is equal to, instead of m1 you can put capital M, that is the mass of earth, and you have got already G, mass of earth. If you want to put E, you can put mass of E earth, otherwise you can leave it as such, it is understood. Then what about m2, that is the small m, divided by r squared. Now this is also force, this is also force, these two are equal, LHS are equal, RHS must be equal. So mg is equal to G into m into small m divided by r squared. So m can be cancelled. Therefore acceleration due to gravity is equal to G into m divided by r squared. Okay. Is that clear? So by knowing the value of G, mass value is constant and radius of earth is also known. Therefore you can arrive at G as 9.8 meter per second square. Okay. Why? Because you already know G M value is constant, R is constant. So by solving this, you can get the value of what? Acceleration due to gravity. Okay. In fact, if you want to calculate accurately, you can do by this also. M is the mass of Earth is 6 into 10 power 24 kg, and radius of Earth is 6.37 into 10 power 6 meter. So you can substitute this value, that is G is equal to, what is the value of capital G? That is given as 6.67, already it is given, into 10 power, you have to by heart all these values, divided by into M. M is this one, 6 into 10 power 24, divided by R squared. So 6.37 into 10 power 6 the whole square. Then you can get 9.8 meter per second square. Okay. Now let us consider three equations of free fall. Free fall. That is, this is the mass M. It is going to fall like this, and this is the Earth's surface. Okay. Of course, we take this total D from the center. This is already known as R. So compared to this R, this is negligible. So we are taken D as R plus H. This is the height of the object. So R is much bigger than H, therefore ignored, H is ignored. So D is equal to R. So this point should be clarified here. Now let us consider the first case. According to fundamental laws of Newtonian motions, Newton's fundamental equation, what is that?
V equal to U plus
Yeah, V is equal to U plus A T.
S equal to
So here A can be replaced by
G.
what?
G.
G, acceleration due to gravity. Okay, therefore this equation becomes, and V becomes U plus G T. Okay. Now we know another equation, S is equal to ut plus half at squared. Is it not? S is equal to ut plus half at squared. So from this you can calculate, that is S can be replaced as H here. That is the distance covered, means height. A is already G. So you have now H is equal to ut plus half gt square. So this is the another equation, and we know V squared is equal to U squared plus 2AS. So you can replace A and S, is it not? So V squared is equal to U squared plus 2GH, right? So when an object is freely falling towards the earth, okay, so this is the freely falling body, case 1 we can say. case 1. Now case 2. Case 2. Here the freely falling body from the rest position, that is very important. When an object, this is just free falling, this is when an object is falling from rest. It means what? U is equal to 0, is it not? From the rest position, right? So the initial velocity will be definitely 0. In that case, we can replace all these equations. Let me say this is equation A, B, C. Now what about this set of equations? There will be V is equal to, now U is 0, so this is GT, that's all. Okay, so in the second case, V is equal to GT. This is the case applicable for what? For the object falling from the rest, that you have to indicate. So this is the equation A. And what about equation B? That is this one. H is equal to, U is equal to 0, so UT is equal to 0. So in that case, H is equal to what? Half GT squared, right? So this is equation B. Okay, and next one, V squared is equal to, U squared is equal to 0. So you have got V squared is equal to 2GH. Are able to find out the difference between the case 1 and case 2? Okay, right. So this is the freely falling body, and this is also freely falling body, but the problem here is it is falling from the rest position. That is very important, from rests. So the object is falling from rests. Okay, this is the second case. Draw this. And the third one is case 3. That is case 3. In that case, we have object. When an object is thrown vertically upwards, okay, so in that case, you are on the here, now you are throwing upward an object, it reaches certain height, okay, and of course this is the radius, and the total distance, you know, that is h plus r. As usual, you can reduce it. Okay, so d becomes r here because r is much greater than h. Done. Now this is mass of earth and this is the mass of the object. Now let us analyze the equation. What is the original equation for freely falling body? V is equal to u plus gt. So in this case, there will be some initial velocity because that is the driving force, is it not? There will be some initial velocity, okay, and the acceleration is, you are going against the acceleration, is it not? So whenever the body is thrown upward, g is, that is a is represented as minus g, okay, take down. So in this case, g becomes minus g. Why? It is just opposite to the acceleration due to gravity. In that case, now we have v plus u plus gt, is it not? V plus u plus gt. Replace this g by minus g. Therefore, v is equal to u minus gt. Do you understand this? So this is a very important equation. Let's call it A. And similarly, H is equal to ut plus half at squared or gt squared. So in this case, it is minus. So H is equal to ut minus half gt squared. So this is the second equation, right? And the third is v squared is equal to u squared plus 2gh. So instead of plus 2gh, you will get minus 2gh. That's all. So v squared is equal to u squared minus 2gh. So this is the third, that is equation C, right? So let me summarize. See, for freely falling body, that is v is equal to u plus gt, h is equal to u plus of gt squared, v squared is equal to u squared plus 2gh. But in case 2, the object is falling from rest, so u is equal to 0, other remaining same. So v is equal to gt, h is equal to half gt squared, v squared is equal to 2gh. Then in the third case, g becomes minus g because it is traveling vertically upward. So v is equal to, instead of g, you have to put minus g. So v is equal to u minus gt, h is equal to ut minus half gt squared, v squared is equal to u squared minus 2gh. Do you understand these concepts? Okay. Note it down. Now let us discuss. Any doubt? Shall I proceed?
Yes, sir.
Now let us find out the difference between mass and weight. Mass versus weight. Mass, weight. It is represented by m, this is represented by w. Mass is the quantity of matter. Mass is the quantity of matter contained in it. Okay? And it has no direction, it has got magnitude only. So, has magnitude. No direction. Therefore, it is scalar. Right? Then, it's a scalar quantity. It remains constant. Remains constant. Does not change from place to place. No change from place to place. Irrespective of the environment or surrounding, it doesn't change. It won't change. Usually it is measured by physical or chemical balance. Determined or measured by physical, but if you want to do it more accurately, you can use chemical balance. So physical or chemical balance, and its SI unit is just kg, kilogram. Okay. Now let us discuss about the weight. Weight is, it is a kind of force attracted towards the center. The center of Earth. We know F is equal to ma according to Newton's law, but it is under this force is under the influence of gravity, so you can change this a into g. So F is equal to mg. If I say F is equal to mg, W becomes mg. Okay, because I said it is the force influenced by the gravity. So weight. So what is weight? It is the force influenced by the gravity, or it is the force attracted towards the center of the earth. Here there is no influence of anything. Okay. And its SI unit is Newton. When you write in word, you have to put small letter nu, n, and when you want to represent this by a symbol, you can put capital N. This is the convention of SI unit. So F, that is W, is equal to m into acceleration due to gravity. I said this is Newton, so in that case m means what? Kg, is it not? And what about acceleration due to gravity, which is nothing but ms power minus 2. So kg ms power minus 2. So 1 Newton is equal to kg ms power minus 2. So this you should be aware, right? Got it? So what is the relationship between 1 kg mass, or you should not say mass, 1 kg weight and Newton? Can you relate? Take down relation between one kg weight and Newton. We know W is equal to m into g, right? So m is equal to 1 kg. Acceleration due to gravity is equal to 9.8 ms power minus 2, right? Therefore W is equal to, you can replace this 1, you can put kg, and into 9.8 ms power minus 2. Okay, it means 1 kg weight is equal to 9.8 Newton. You understand this? Because already we know Newton is equal to kg ms power minus 2. Got it? Okay. Do you understand this? Is there any doubt? What are the importance? So you should know the importance of the universal law of gravitation. So we will try to explain that one also. Take down importance of universal law of gravitation. take down the first point. The force that binds us, to the earth. This is a very important one. Otherwise, we'll be flying. Is it not? Next, the motion of the moon. The motion of the moon around the earth can be illustrated with the help of this Newton's law. Third point, the motion of the planets, motion of all the planets around sun. Around the sun. Okay. And then you have got lot of tides on ocean, is it not? It is due to moon and sun. So the tides, the ocean tides, is it not? So the tides are due to what? The moon and the sun. Okay. Now let us try to calculate the weight of the object or body on moon. Let us calculate this. This is the weight of an object or weight of a body on earth. Okay. And this is the weight of the body on moon. Right. We already declared weight of the object is equal to what? That is G is a kind of force, is it not? So you can put G, mass of earth and mass divided by radius of earth, in this case square. So this is the weight of the body on earth. What about the weight of the body on moon? That is equal to G M mass of what? Moon M into mass of the body divided by R mass of, radius of the moon. Okay, please take down. Now let us calculate the ratio between the weight of the moon and weight of the earth. Okay. Let me say this is equation 1, this is equation 2. So equation 1 divided by equation 2 divided by equation 1. Therefore weight of the moon divided by weight of the earth is equal to, now G can be cancelled, is it not? Otherwise you let us put, and finally we will cancel. So you have got G, Wm. So G into M divided by R squared, Rm squared, reciprocal, is it not? That is divided. So G into M divided by Re squared. You have to reciprocate this. So that is equal to what? That is G is cancelled here. Now the remaining is M, and this M is also cancelled, the same mass, is it not? So you can have M divided by Rm squared, and this is reciprocated, that is Re squared divided by M, what is that? Earth. Okay. This is, earth. Right? So it means Wm is equal to We into, take down, M, what is this M? That is mass of moon divided by mass of earth, right? Into radius of earth divided by radius of moon whole square, correct? Okay, got it? Now let us replace all these values by the constants. So given mass of earth, what is mass of earth? Just now I declared 5.98, or you can put 6 also. So 5.98 into 10 power 24 kg. And the mass of moon, how much? 7.36 into 10 power 22 kg. And then radius of earth is 6.4 into 10 power 6, how much? Meter. Radius of moon 1.74 into 10 power 6 meter. Now let us substitute all these values in this equation. Therefore, Wm is equal to weight of body on moon is equal to weight of body on earth into, you can substitute, instead of m you can put mass of moon 7.36 into 10 power 22, right, divided by, and mass of earth 5.98 into 10 power 24, correct, into, and what about this? Radius of earth 6.4 into 10 power 22 divided by 1.74 into 10 power 6, the whole square. Okay, now what you can do? Wm is equal to We of, you can take all the powers on one side, so 7.36 divided by 5.98, and 10 power 24 becomes 10 power minus 24, is it not? So it becomes what? 10 power minus 2, correct, into, what about this? 6.4 squared, correct, divided by 1.74 squared into 10 power, what is this? 24, okay, 10 power 6, is it not? 6.4 into 10 power 6, sorry, okay. So 6 means 10 power 6 whole squared, how much? 6 into 2, a power m whole power n is equal to a power mn, so 10 power 12, correct. And what about this? This is also 10 power 12, so you can cancel this, okay. Now when you work out all these things, you will find that this is almost weight of the moon, okay. Weight of the moon is equal to, that is 6 times of the 1/6 of the earth divided by 6. So it means weight of any body on moon divided by weight of the same body on earth is in the ratio 1:6, okay. Or you can declare weight of the, it is not weight of the moon, weight of the body on moon is equal to 1/6 of the weight of the what? Body on earth. Is that clear? So this is a very important equation. Now what is your weight? Will it be around 40? 45. Okay. Let me say 42. Okay. So take down. Calculate the weight of January on moon, taking weight on earth. Her weight on earth is 42. Can you calculate? So weight of January on moon is 1/6 of 42. You will be just 7 kg. That's all. Okay. Right. I'll give you one sum. Try to do it on the board. Take down. Go right. Mass of an object. Come. Mass of an object is 10 kg. Mass of an object is 10 kg. Okay. What is the weight on earth?
Sir, the 10 kg is on the weight of moon.
I asked simply what is the weight. I have given mass. You have to find out the weight.
10 kg.
I have not weight of earth. That's a weight on earth.
10 kg.
That is wrong. I said there is a difference between weight and mass. No. So I have given mass only. I have asked weight.
W equal to mg.
So W is equal to mg. You have to use that formula. Do you understand this? Right. Proceed. So W is equal to mg. Since I was talking about the comparison between weight and the moon, your mind is set there.
98 kg.
So W is equal to mg means 10 kg into what? 9.8 meter per second square. You have to put the unit properly. So that is equal to 98 kg. So when you put kg, you have to put small letter k, not capital K. So if you put capital K, it becomes a Kelvin. So kg, meter per second square, and that can be called a Newton. So weight is 98 Newton. So whenever you call weight, it's a force. Either it should be represented as a kg meter per second square or Newton. Are you able to follow? So the final answer is 98 Newton. Okay. Shall we try one more sum?
Yes.
Take down. An object weighs. An object weighs 10 unit. An object weighs 10 Newton when measured on the surface of earth. It means on earth. It means how you can represent WE. Right? What would be its weight when it is measured on the surface of the moon? So WM is asked. So we know the equation WM is equal to WE by 6. That's all. So get me the answer.
2.5.
No. 1.67. 666 in Pogo. You can put 67. Unit. Newton. Okay, give it in kg meter per second square. Is it clear? Right, very good. Can you find out the acceleration due to gravity from this answer for moon? WE take down. You can write here. Put a line. WM, I said moon. So WM is equal to mg. Is it no? Okay. And here you have to find out the mass is constant. It is not going to be changed. So find out the mass. If it is 10 Newton, what could be the mass?
10.
Mass. Weight is 10 Newton.
98.
10 by?
9 by
See,
9.
mg is equal to 10. Make a note. mg is equal to mg is equal to 10. Are you able to follow? What is m? 10 by g on earth, is it not? On earth. You know the value of a g.
9.8.
Put 9.8. Now you are able to find out the what? The mass generally, irrespective of the planets. Okay. So now you have m is equal to 10 by 9.8. So using this m, can you find out the acceleration due to gravity of moon? You can erase this side. Proceed like this. Wm is equal to, what is that? Wm is equal to m into small m. G, acceleration due to gravity of moon. Put a gm. I asked gm. You know already wm. You know mass. So from this you can calculate the acceleration due to gravity on moon also. Can you try? So wm, so gm is equal to, write down, gm is equal to wm divided by small m. Do you understand this? Are you able to follow? Right. What is wm here? 1.6. 1.67. 1.67 divided by, what is m here? 10 divided by 9.8. You can reciprocate. So 9.8 divided by 10. You cannot use this mass. Here mass is 10 by 9.8. Is it not? So put 10 by, you can reciprocate. So 1.67 into 9.8 divided by 10. So let us find out the value. Use the calculator and find out. Do it. First multiply 1.67 into 9.8, then divided by 10, that's all.
1.636.
You already divided, divided by 10. 1.67 into 9.8, how much? Sixteen point,
16.36.
that is divided by 10 means 1.6366. It means acceleration due to moon is totally different. Are you able to follow? So how much? Gm is equal to 1.636 meter per second square. Whereas acceleration due to gravity of earth is
9.8 meter per second.
horrible follow, and that is why you are able to have a different weight, okay, because the mass is less. Okay, we can have another equation also based on this. Let us proceed. You can erase that one. Now you can have such type of interesting questions also. Take down, you can write completely. How does the force of gravitation between two objects change when the distance between them is reduced to half? Okay. So you should have always some set of equations. See, when you have got some equation, you can derive in such a way that the comparison can also be determined from our derived equation. Now listen, from 2, what you have written, reduced to TO, reduced to half. Now what do you mean by this? How does the force of gravitation, underlying force of gravitation, how can you represent this by symbol F? That's the force of gravitation, is it not? So put F, you can mark as F, just to put a F, round it. This is F. Between two objects, when the distance, underlying distance, how to mention the distance?
Yes.
Distance D between two objects D. Okay, so that is the distance between the two objects, is it not? Is reduced to half. It means they are talking about two forces, is it not? F1, F2. You can mention that F1, F2. F1, comma F2. And here you are taking two distances, D1 and D2. Now we are going to study what could be F2. Okay, so you have two forces, take down, two forces. Two forces, F1, F2 is equal to F is equal to F1, F2, comma F2. F1, comma F2. And then two distances. Two distances. Two distances. D1, D2. D1, D2. Okay, so the second distance is half of it, is it not? So D2 is equal to D1 by D2. Do you understand this? D2 is equal to D1 by D2. You are talking about second. D1 by D2. D1 by 2. Half the distance when D1 by 2. Okay, so what is asked here? What will be the relationship between F2 and F1? Okay, find out F2 by F1. Is equal to what? So this is the question. Okay, so how we can proceed? Take down. We know already F is directly proportional, inversely proportional to d1 squared, is it not? D squared, 1 by, inversely means 1 by d squared. So we are taken two forces, F1 and F2. F1 proportional 1 by d1 squared, d1 squared. F2 proportional 1 by
D2.
d2 squared. So what is F2 by F1? Write down, F2 by F1 is equal to, you can mention here, so 1 by d2 squared, is it not? d2 squared whole divided by 1 by d1 squared, is it not? Put a vertical line. Now you can reciprocate, is it not? So F2 by F1 is equal to what?
1 by D2
Ah. Square by 1. It means F2 by F1 is equal to d1 by d2 whole square. Am I right? Now you can substitute d2 by d1 by d2. Is it not? It is given. Go there. What is given? d2 is d1 by. Can you substitute? So you put the box here. You put the box. F2 by F1 is equal to this one. Last one. Last you are written. F2 by F1 is the last one, ma. Put it in the box. This is the equation you should have already derived. Horrible follow. If you know this equation, you can easily substitute and get the answer. So F2 divided by F1 is equal to what? What is D1 here? As such D1. What is D2? D2 by D1. So it is reciprocated. So put D1 whole square, entire whole square. So that is equal to D1 can be cancelled, is it not? So 2 squared is equal to 4. Got it? So it means, put 4 properly. It means the F2, the new force, F2 is 4 times of F1. Do you understand this? Okay? 4 times of, no, put 4 into F1, that's all. Put it in the box. Do you understand? So when you reduce the distance, to half, initially it was 1 meter, it is reduced to half meter. It means the force is 4 times increasing. Do you understand this? Or you will follow? So F2 is increasing 4 times. So F2 is equal to 4 times of the F1. So can you do such type of problems? Okay. So instead of 1 by 2, if I put 1 by 4, 1/4, what will happen?
16.
16. Very good. Why?
Square.
Huh?
D1 and D2. D1 and
16. நல்ல செக் பண்ணி பாரு. D1 by 4 அப்போ 4 ஸ்கொயர்னா 16 into 4 இல்லை 64 ஆகிடும். I mean F புரியுது அது? You can try. You can change this as, so have you noted this one? Now let us try with 1/4 distance. So put F2 by F1 is equal to, D2 is equal to D1 by 4. Now look at the impact. Now replace all this and you can replace the final equation. So instead of 2 you can put 4. Is it not? So it means 4 squared. It becomes 16. Sorry. 16. So 16 times it is increasing. Is it not? So F2 becomes 16 times of F1. Got this? Okay? Right? Good. Okay, so let us discuss in the next class, right?